Audio Jungle.
What is light detection and ranging, LiDAR? How would you like to wave your magic wand, and all of a sudden find out how far everything is away from you? No magic wands were necessary. This is how LiDAR, light detection and ranging, works. Of course, without the magic wand. Let's demystify light detection and ranging. Hopefully, after reading this, you will go from zero to a LiDAR hero. LiDAR 101. LiDAR is fundamentally a distance technology. From an airplane or helicopter, LiDAR systems send light to the ground. This pulse hits the ground and returns to the sensor. Then, it measures how long it takes for the light to return to the sensor. By recording the return time, this is how LiDAR measures distance. In fact, this is also how LiDAR got its name, light detection and ranging. How LiDAR works. LiDAR is a sampling tool. What I mean by that is that it sends over 160,000 pulses per second. For every second, each 1 megapixel gets about 15 pulses. This is why LiDAR point clouds create millions of points. LiDAR systems are very accurate because it's being controlled in a platform. For example, accuracy is only about 15 centimeters vertically and 40 centimeters horizontally. As a plane travels in the air, LiDAR units scan the ground from side to side. While some pulses will be directly below nadir, most pulses travel at an angle, off nadir. So when a LiDAR system calculates elevation, it also accounts for the angle. Typically, linear LiDAR has a swath width of 3,300 feet, but new technologies like Geiger LiDAR can scan widths of 16,000 feet. This type of LiDAR can cover much wider footprints compared to traditional LiDAR. What can LiDAR generate? 1. Number of returns. Imagine you're hiking in a forest. Then, you look up to the sky. If you can see light, this means that LiDAR pulses can go through too. Also, this means that LiDAR can hit the bare earth or short vegetation. A significant amount of light penetrates the forest canopy just like sunlight. But LiDAR won't necessarily only hit the bare ground. In a forested area, it can reflect off different parts of the forest until the pulse finally hits the ground. By using LiDAR to get bare ground points, you're not X-raying through vegetation. Instead, you're really peering through the gaps in the leaves. When it hits the branches, you get multiple hits or returns. 2. Return number. In a forest, the laser pulse goes downwards. When light hits different parts of the forest, you get the return number. For example, you'll get the first, second, third returns until it finally hits the bare ground. If there's no forest in the way, it will just hit the ground surface. Sometimes a pulse of light doesn't reflect off one thing. As with the case of trees, one light pulse could have multiple returns. LiDAR systems can record information starting from the top of the canopy through the canopy all the way to the ground. This makes LiDAR valuable for interpreting the forest structure and shape of the trees. 3. Digital elevation models. Digital elevation models, DEM, are bare earth, topographic, models of the Earth's surface. By using only ground returns, you can build a DEM. But this is different from digital terrain models, DTM, because DTMs incorporate contours. By using a DEM, you can generate additional products. For example, you can create slope, rise or fall expressed in degrees or percent. Aspect, slope direction. Hillshade, shaded relief considering illumination angle. 4. Digital surface models. As you've learned, LiDAR peers through the forest. Eventually, the light reaches the ground. Then, we get a bare earth return. But what about the first return that hits the tree? A digital surface model, DSM, incorporates elevations from natural and built surfaces. For example, it adds elevation from buildings, tree canopy, power lines, and other features.